All right, the problem I'm going to be doing is a 220-gram ball collides with a wall. The figures show the ball's velocity and the force exerted on the ball by the wall. And what we're asked is, what is the final velocity, the ball's rebound velocity? So we're given two figures. We're given the velocity versus time graph and the force versus time graph. So we're gonna be able to use the information from these two graphs when we're solving the problem. So this is our work. We know that the change in momentum or the impulse equals the force times the change in time over which that force is exerted. So that's going to be the graph on the right. So over the course of 8 seconds, a constant force of 500 newtons is applied. So we can say that the change in momentum is 500 newtons times 0.008 seconds. So it's applied over 8 milliseconds. So we just need to change the units so that it fits with the units of newtons, which is kilograms meters per second squared. So if we do that, we get 4 kilograms meters per second squared, which does line up with our normal units for change in momentum. And then we also know that change in momentum equals mass times change in velocity. And we can use the graph on the left for this. We know that the change in velocity can be written as the final velocity minus the initial velocity. And we are told the initial velocity is -10 meters per second. And we're told that the mass is 220 grams or 0.220 kilograms. So since we just solved for the impulse, we can use that to solve for the final velocity, which is our only unknown now. And we get that to be 8.18 meters per second. So our rebound velocity is 8.18 meters per second, whereas our initial velocity was 10 meters per second in the opposite direction, which does make sense. It's going to lose some velocity into some energy into the wall. So it's going to rebound with less velocity in the opposite direction. All right. And then just some things to think about. This problem is good because it uses the impulse formula to find a component of the change in velocity. That's just making people realize you don't just have to solve specifically for the change in velocity. If you're given either final velocity or initial velocity, you can use that to find the other one. And then we have two different formulas for change in momentum. We have it for force times change in time and also for mass times change in velocity. So just being able to manipulate both of those to find the value that you want. And then in this one, it was really important to make sure you're using the correct units. So you want them to line up with the units of newtons, which for mass is kilograms, and then for time is seconds. So just making sure those are all lining up